All right, there is also another form of integration by parts, and this is called the tabular method, the tab method. This can be useful in certain situations, especially we can think of this as a bit of a shortcut method for integration by parts, especially for problems that involve multiple iterations of integration by parts. So this method is useful whenever our u value can be assigned to the polynomial. So if our u value can be assigned to the x to the fourth or to the algebraic portion of our integrand, then our tab method can be used. And the way we decide is we again look to our p to determine if the polynomial or algebraic expression is the appropriate u value to be assigned. And again, the tab method is especially useful for a polynomial of degree higher than 1, and this is when we have potentially a repeated portion of the integration by parts that will keep coming up. So before I go down to the examples, I want to show example 5 having to go through integration by parts so that we can see the benefit of this tab method when we can see what why we need this shortcut or why it's useful to have this shortcut. So let's look at example 5 using integration by parts. The problem says integral of x to the fourth times sine of x dx, and we look at our acronym LIPET. We see that our algebraic or our polynomial versus our trig function. The polynomial is going to take precedence over the trig function, right? Polynomial comes before trig, and so our u value is x to the fourth, our dv is sine of x. We find the derivative, x to the fourth becomes 4x cubed, and the integral of sine becomes negative cosine. And so we plug into our formula, u times v minus the integral of v du. We get negative x to the fourth cosine x, because the negative from the cosine we can pull to the outside, minus the integral of 4x cubed negative cosine of x dx, which we can simplify. The two negatives can cancel out to be positive integral of 4x cubed cosine x dx. Okay. Now this portion is done, but we have to resolve this second half because we see the integral sign in front. And we're left with 4x cubed cosine x dx. And if you look at this, you would have to go through integration by parts again, because you have a portion that represents polynomial, second portion that represents cosine. So this is essentially having to do the problem over again just for this inner portion of our problem. So our u value is 4x cubed, our dv is cosine x, derivative is 12x squared from the 4x cubed, and the integral of cosine is sine of x. Okay, we plug into our formula again, and we're left with 4x cubed sine x minus the integral of 12x squared sine of x dx. And then the integral here again, we have to go through integration by parts. And this is actually going to continue 2 more times, and you can imagine how taxing this is to do just for one problem. So now there is a pattern that's going to come from this that will allow us to take out a lot of these steps, and that's what the tab method does for us. Okay, so the steps that we're going to take, we're going to create 2 columns, one for the u, one representing the u value, the other representing the dv. Okay, again, the u value must be the polynomial or the algebraic expression, and the dv will be the other portion. So back to example 5, we have x to the fourth versus sine of x. Again, polynomial is going to beat out the trig function, so x to the fourth is u, dv is sine of x. We create 2 columns, so we have u and dv, and we put our u value under the x to the fourth as the first value in the column for u, and then under dv we put sine of x. Okay. Now the fourth step, find the derivative of the polynomial u until reaching 0. So we're starting off with x to the fourth. We're going to keep finding the derivative until we get to 0. And each time we find the derivative, we're going to write that value down. So x to the fourth becomes 4x cubed. We find the derivative again, multiply the 30 times 4, subtract 1, so we get 12x squared. Bring down the 2 again, we get 24x. 24x becomes 24. And finally, the derivative of a constant will bring us to 0. Okay. Step 5, we're going to find the integral of dv the same number of times. So just to remind us, the integral of sine is negative cosine. The integral of cosine is a positive sine. So sine becomes negative cosine. Integral of negative cosine becomes negative sine because the negative will stay. There's not going to be a sign change from cosine to sine. Okay, integral of negative sine becomes positive cosine because there is a sign change from sine to cosine. From cosine, integral of cosine is positive sine, as we see here. And finally, the integral of sine is negative cosine. Okay. Assign alternating signs to each column and well, actually just to the column in front of u. So we start off with plus, and then we say minus, plus, minus, plus, minus. And we always start with plus, and then we always start with positive, and then we alternate from there. Okay, the reason why we have alternating signs is because we are stepping through integration by parts multiple times. And each time we step through integration by parts, the formula is going to call for a minus integral of v du. So this minus sign here, this minus sign here is going to keep changing the sign of our product. Okay. And finally, we're going to add the product of diagonal terms. So we're going to start with the upper left, and we're going to draw a diagonal arrow to the term in the other column. So we're just going to go diagonal down, and this just shows us which pairs we're going to multiply together. Okay. Finally, we're going to add the product of diagonal terms. So x to the fourth times negative cosine of x. Okay, that's our first term. Negative 4x cubed times negative sine of x becomes positive. 12x squared cosine x, negative 24x sine x. And finally, negative 24, because of the in front of the negative cosine here, negative 24 cosine x, and then finally plus c. Okay, example 6. This is from example 1. This is just to show that we can also go through tab method from a problem like example 1 because we can assign the u value to be the algebraic portion. So I would just encourage students to always take the tab method as long as you can assign the u value to be x. It'll just be a lot cleaner and a lot more efficient to go through once you know the procedures that takes place. So our u value is x, our dv is e to the x. Again, we can assign u to be x because algebraic or polynomial will take precedence over exponential. So under the u column, we have x, derivative becomes 1, and then 0. Integral of e to the x, simply e to the x, so we write that twice. We assign positive, negative, starting with positive, so positive, negative, positive. And then we match up the diagonal terms. This shows you which one you're going to multiply together. So x times e to the x, that's the first term, minus 1 times e to the x plus c. Okay. Example 4, we see that we have x to the cube versus natural log of x. Now, if we go back to our acronym, which tells us the order, we see that L comes before polynomial, logs before polynomial. So that means our u value is natural log of x, and our dv is x cubed. Okay. Even though we want to take care this problem using tab method, we cannot, because our u value is not a polynomial, which means that if we find the derivative, we're not going to be able to have a stopping point like a polynomial where we can end at a 0. So that means we'll have to force to use integration by parts. So our u value, we have to find the derivative. Du becomes 1 over x dx. dv is assigned to be x cubed, and so x cubed becomes x to the fourth over 4. We're finding the integral using power rule. And then we plug into our integration by parts formula, u times v minus the integral of v times du. This left part is finished, but this side we've got to keep working with this. So we can pull a 1/4 out. We can cancel out one of the x's. So then we're left with x to the fourth over x. And one of the x's cancel out. We have 1 over 4 integral of x cubed. Integral of x cubed is simply x to the fourth over 4. Multiply this with our coefficient. We have 1/16 x to the fourth. But then we don't want to forget this negative sign, this minus sign. So finally we have x to the fourth, natural log of x minus 1/16 x to the fourth plus c. All right, final example is just to demonstrate that in the overall scheme of things when you're studying for your AP exam or for the final exam, that when you see an integral problem, you want to go through this checklist. Okay, first, you want to see, can I expand this problem? Can I simplify? Can I separate the terms? And can I resort to simply using power rule? Okay, if you can, then that's always the first thing you check for. If this is not sufficient, then you go to your next option, which is U-Substitution. Okay. And on the AP exam and the final exam, these two will be the ones that come up the most often. Your last resort will be integration by parts and or tab method. This is usually not going to show up on the AB exam, but it has shown up before, so we're just covering all our bases here. Okay, so for example 8, we see natural log over 2x. We go down our checklist order. We can't expand, simplify, power rule. We have natural log involved, so we go down to our next option, which is U-Substitution. So let's go through and try U-Substitution. Okay, if we're trying to solve this U-Substitution, then maybe we can let the natural log be the be the u value. So then if we go through that, our goal is to see if this is enough to cancel out this x, and then this 2 is okay because that's just a coefficient that we can pull to the front. So our u value is natural log of x, derivative is 1 over x. We want to solve for dx so that we're trying to get everything, we're trying to replace everything in terms of u. So we're going to solve for dx. So dx is x du. We make our substitutions and see if we can get everything to cancel out cleanly and leave us with the problem in terms of u. So pull out the 1/2, natural log over x dx. Natural log of x gets replaced with u. X stays initially. Dx gets replaced with x times du. The x's cancel out, numerator and denominator. We're left with the 1/2 in front, integral of u du. So then we have something, x is canceled out. We have a rule that we can apply, which is power rule. So then u becomes u squared over 2. Multiply this through, we get 1/4 u squared plus c. And then finally replace our u value back in terms of our original variable, 1/2 natural log of x quantity squared plus c. So this goes to show that U-Substitution is the appropriate way to solve this problem, and integration by parts is not going to be able to solve this problem for us.